my doubt was in one sentence that said that a sufficiently compact mass can can deform space-time to form a black hole.
What is space-time?
And I didn't understand.
No, what is space-time?
Space-time is a four-dimensional entity.
What is that? See, if somebody says four-dimensional entity, does it explain space-time?
No, with the three spatial coordinates x, y, z, and that fourth dimension is taken as time coordinate.
Are you able to visualize it, Amma? If you are able to visualize it, you explain it in that way. Don't give definition statements. When I am asking what does it mean, you must be able to visualize it. Are you able to visualize it?
Yeah. We will start I visualize it in terms of dimensions. So if we can consider a point is when you talk about a zeroth dimensional entity, it can be a point which is having no measurable things like length or breadth or anything like that. But then point becomes a hypothetical concept. So from that point, if you move to first dimensions, if you are able to arrange those points in a straight line, you can go to one dimension. And then if you are able to arrange those lines in the perpendicular directions, you get the second dimension with length and breadth.
Mm-hmm.
And then the length becomes a square. So if you are able to arrange those squares in the third mutually perpendicular direction, you get a cube, which is x-axis, y-axis, and the z-axis. So that becomes a third dimension. If you vise it dimension, that is, if that's a cylinder, like if you say a cube or a cylinder, you can only see a 2D projection of that. At that time, you can only view one portion of it. So that is called the 2D portion. So if you 2D projection, so if you can keep time as the fourth dimension, you will be able, in that fourth dimension, you will be able to visualize this three-dimensional entity.
So where is the doubt now?
So that's what we go about space-time.
No, you tell me the sentence which you started with.
The theory of general relativity predicts that a sufficiently compact mass can deform space-time to form a black hole.
Yeah, so what is it?
I didn't understand that sentence.
See, imagine now the same what you said. 1 dimension, 2 dimension, 3 dimension, 4 dimension. Let me put more realistic. You gave again theoretical explanation only. It's a mathematical explanation. You are from physics background, right?
Yes.
Did you use any physics in explaining that? Consider a ball instead of point. Point is mathematics, ball is physical entity. When you move the ball in a line, there is a linear one-dimensional motion. When you make the ball to move, maybe you are hitting somewhere, it returns back, it creates, on a ground it moves here and there. That is in a space, in a two-dimensional space. When you float the ball, now assume that the ball you are putting it in a wave, in a sea. It is not in one dimension, it is not in two dimension, it's in three dimension. It moves in x, y, z directions because wave is taking it, right? Does it not go up and down, x, y, z, all the directions?
Yes, x, y, z direction.
So the space is, every planet in the space is like a ball which is kept on the sea wave. At some time you will see it doesn't even go on top of the wave, it could dip down sometime, because there is one wave coming, another wave coming, another wave coming, it hits and disappears sometime. Are you able to see the ball moving here up and there? Sometimes the wave will hit there and there, it may go down, it disappears. So in the space also there are some locations. Assume that there is a vorticity. In a vorticity, what happens? In a wave there can be vorticity points. So what happens is, when it is in the wake, it goes down, it disappears. The ball will not be visible. So is it in 3 dimension, is it in 1 dimension, it is 2 dimension, or is it is taking time? The time is what defines. At one point of time it was visible, next point it is not visible. So
Yes,
time comes
uses-
into factor. It's X, Y, Z and time. Similarly, a aircraft or satellite is moving. It has got tilt in different directions.
Yes. You use time for find the motion.
The earth itself revolving, rotating, tilting in all directions. It is not XY, it is XYZ, and the time, based on the time it moves from different, it is not XYZ. There is another reference system. Solar system has got another reference system. So you know, on this date, this month, at this point of time, because it goes around another dimension. So when you consider that it becomes in a different time, you must know where is it. So time factor, always 4 dimension, space and time. Any activity when you do it, space and time. It is not something extraordinary. Every physics, when we explain physics, when we visualize things, it is time and space. My movements, the planetary movements, it is space and time. So in that, what happens is, so it's like the wave can be considered as like a net. The ball need not be on a surface of a sea. You consider it is like a fiber, a net, a football net or volleyball net. Tie it very properly and you are putting the ball there. So what happens is, when the ball is put on top of the net, it vibrates, it jumps. Got it? So that movement is where, whenever it goes, it has got a depression. So in that depression, when you are looking from horizontal way, the depression, you will be able to see the ball. But assume that the depression is too low, the force is too much, you are hitting it. At one point of time, it becomes invisible. So what is invisible is called a dark space.
That ball will go through the dimension of space, and due to the force, the depression will become so large.
Yeah. So which you cannot predict it. It becomes so chaotic. You are not seeing it. So it's like a sink. There are 2 concepts in physics. One is sink and another one is source. So it's like a sink.
So the 4th dimension will not be visible.
Yeah, the 4th dimension is the time. The time predicts where it goes.
So every mass will deform slowly.
With a force which makes it, it could be gravity, it could be universal gravity, it could be electromagnetic energy of any form. So the energy is sufficient enough, too large. So in the relativity theory, general relativity, we have to talk about a ball. Now we are talking about the ball itself is going or making a depression in the surface.
Yes.
But that is under the belief that the ball is so strong and stable, the net is tiltable. But assume the net is very strong and the ball happens to be like a sponge ball. Now what will happen? The ball itself will deform, na?
Yeah. Right.
Understood? Now assume instead of now you are imagining the ball like a soft toy ball or something. Instead of that, imagine it's an ice ball. So assume that the mat which you are using is an iron bar. It will disappear. It goes. It deforms. It goes inside the net. See, how do we know which is stronger? In the space, the electromagnetic energy, which I am talking about, like a strong net. Sometimes the planet itself destroys. See what is happening when now in the Gujarat coast there is a hurricane. What is wind? What is hurricane? It's only an energy. It's a movement of energy. And what's happening to the items there? Everything is deformed, right?
Yes. Strong force.
Yeah, strong force can deform everything. It's not very imaginative. It's a realistic thing which happens on earth also. No? A huge force comes. Everything devastating. What happens? Everything disappears. Imagine a 150 kilometer. It's a huge concept to be understood. Now we people are worried today. In Gujarat coast 100 kilometer above 100 kilometer, the wind is blowing. The trees are falling. Electric lines, poles are very strong. Everything is on the ground. What is the speed of earth? What is the, it's not radius. It is the semi-major axis, semi-minor axis, but consider it is radius. So what is the radius of earth? For mathematical purpose, let us consider earth as a spheroid. Now tell me, what is the radius of earth?
6,000 kilometers.
Yeah, approximately 6,000 kilometers. Now what is 2 pi r? Now I am allowing you to compute it. So it becomes 6,000, 2 pi r. So multiply into 2. And pi, you don't take it 3.14, take it as 3 only.
3.
2 pi r in how much time? 24 hours. So 24 hours. So you will get the speed. 6,000 multiplied by 2 into 3, that is 2 pi r, divided by 24. So 2 into 3, 6. 24 and 6 can be cut. So it becomes 4. So how much you got? 6,000 by 4. The earth is moving and all on a sudden it stops. What will happen? Every one of us on the ground
will flung out.
Actually it doesn't happen because earth is not the physical earth. Earth has got an atmosphere also. So when it stops, it doesn't stop with the earth alone. The atmosphere also stops. So we will not run away like what people imagine. It doesn't happen. But assume the earth stops and gravity also is lost. Otherwise the atmosphere is standing close to the earth. It is catching below. It's like you are on top of a car, the car stops. Everybody says we will run away, fly away and all that. But you cannot imagine somebody is on the earth with no ties. We have a tie. We are all pulled it to the, it is like a box which is tied to the car. Not the carrier of the luggage. Without the ties, things may fall. But if it is tied properly, nothing will fall. So earth is not with an atmosphere. Atmosphere is what is tying us. The atmosphere is there because gravity is there. So it doesn't assume the gravity is also lost, because gravity is a force. The speed in which it moving is also force. On the earth, nothing may happen. But imagine in the whole universe, in the Milky Way galaxy, it is not the way what we think. There can be hitches, there can be down, there can be variations in electromagnetic energy, there can be variations in the gravity, there can be a variation in the speed in which it moves. Anything can happen. So what will happen? Sometimes something will disappear, something will appear, all that will happen.
We will not move in that tangential direction which everyone sees. That will not be possible.
No, everybody will say when the earth stops, everybody will fly.
In the tangential direction.
Actually, it doesn't happen because we are being pulled by the gravity. Only if gravity is lost. See, there is something called gravity which pulls all of us down, right? It is like in a vehicle, the item is kept on the carrier. Do you think when the vehicle stops, if the bonnet also goes away?
No.
Tire will go in different sides. It will not go because all of them are tied, right? So there is something which is pulling. Now, how do you understand this? Assume that you have a magnet and you have an iron small ball kept on that, or a bar is kept. You move the both iron bar very fast. You stop the iron bar. Do you think the iron bar will move, slip away from the magnet? Yes, yes, it could happen. When it could happen, assume the magnetic bar is very small and the iron bar is very thick, very huge one. The mass is so huge. Then what will happen? Once it is stopped, this may slip off. But earth is too huge. Anything on earth is, compared to the whole big earth and the gravity, we are nothing. Suppose when the earth stops moving, everybody would have been flown away. I am sure when the earth is moving with 1500 kilometers, everybody would have been flown away. Why are we not See, when it is stopping, why you are saying it will move in the tangential motion. Suppose when the earth stops, it is moving in tangential direction. You imagine the earth is moving that fast, 1500 km per hour, we should have been washed away, right? Why is it not happening? Because the gravity is pulling us. You should imagine the other way also, right?
Gravity is.
Yeah, it's huge. So it's pulling all of us. Now assume that it can be read along with the momentum also. Now assume that some I don't know whether you know the quantum jump. What is quantum tunneling? Now you tell me.
Electrons have the property of waves, so they can tunnel through barriers.
Yeah.
Just like how trains we make a tunnel, and like classical particles cannot tunnel through barriers, but quantum particles can tunnel through barriers.
Actually, that is quantum jump only. You are jumping through the barriers, right?
Oh.
Understood?
Yes, yes. So, yeah. Quantum. Another word for quantum is quantum jump.
No, the phenomena, what happens? The whole discussion started with what? The black hole, right?
Formation of sphere black hole. But
Yeah, the black hole is like a quantum tunnel. The black hole is like a quantum tunnel, right? It is escaping.
it, Doctor, I have when you told about quantum jumping and tunneling, both are different factors, right?
See, what happens is there is assume that there is a singularity. Singularity is like a sinking phenomena.
A singularity where every laws of physics will go not apply.
What is happening in singularity? See,
In
now
singularity,
you see, why did I ask you that? There are two things which happens. See, in the black hole, because of the electromagnetic energy pull in different directions, it disappears inside. That is what you are telling us, quantum tunnel. When it goes inside and disappears, it is quantum tunneling. So actually black hole is a quantum tunneling. Now what I am asking is quantum jump. What is quantum jump? See, assume that you are twisting something. Something can go inside that, something can go out also, right?
Yeah.
It can disappear from that place. That is called quantum jump.
Okay.
See, actually I want you to understand quantum tunneling only. I thought maybe when you have got a glass of water which you are stirring, it goes inside, but it need not go inside. Something can go out also, right?
So,
It's looking at different directions. What you want is what you are looking. What you don't want also sometimes you have to look. Realize it. Are you physically seeing it?
yes. If the inward force is more inside, right? Is there a play of force?
It's all force. See, now I am saying when the ball goes inside the net, it disappears inside the net. But not necessarily always. Instead of that, the ball is it's like a rubber ball. Once you put it, it may make a dip. It may disappear also, right?
Yeah.
When you have a drop of water falling in a water which is stable. One drop of water when it is falls, if you look at it, the phenomena in which the water moves, the water may go inside because the water droplet which is on the surface, it goes inside. But once it goes inside, there are a lot of waves which is happening. What are the waves? Actually, it is jumping out from the center point. Have you seen the form in which the waves are formed? See, when you put a ball or maybe a stone which you are putting in a water, the stone will go down and the waves will form. But the stone is going down. Same thing. When you put a drop of water also, the drop of water will split into bits and pieces.
Okay. it will fall. Yeah.
It goes inside.
The waves will remain.
So it goes inside. It is actually making like a black hole. It is disappearing. Don't consider it as a water surface and a droplet of water. Consider it as a universe in which some material, some energy, it's like a vorticity, the cloud is moving. Same way. Something will fall inside, something goes out also. So quantum tunneling will happen, quantum jump also will happen. Outwardly it is called a quantum jump.
Okay.
Are you
Yes,
getting?
doctor. Yes, I understood.
See, I had a student when I was in US. One of the 9th class girl wanted to do a project on quantum tunneling. So you look at DrTPS quantum tunneling. She has beautifully explained it. Their 9th grade children have got assignments and international competitions on physics. So quantum jump, the word comes when you have got a singularity. From the singularity, the black hole appears. When the black hole appears, understand it's like stirring the water in a glass. The vorticity creates a deep depth inside. When deep depth inside, the water is full, definitely something falls outside the glass also.
Okay.
Understood? So the whole universe have got a energy, the whole universe have got a space. Something goes in, something goes out. Everything happens together. It's a big magic.
Oh, that is when we talk about radiation, Hawking radiation and all, through the event horizon.
Yeah, we are not able to predict the way in which it happens because everything is chaotic. What is chaos? Chaos is what cannot be predicted.
Random.
Yeah, it's too random. See, for example, when you have got a pipe, you open the pipe, the water flows like a linear motion. After some time, when the pipe is fully opened, it bursts out in all directions.
Yeah.
Understood? And understand the whole entropy. What is entropy?
The measure of orderness.
The whole energy in the universe remains same. So it has to balance somewhere, right? Suppose something is disappearing. Suppose you have got a wind is coming. The wind is coming. In the sea it is very powerful. When it comes to the land it becomes less. That means what? It is distributing somewhere, right? It is lost. Possible. Assume that you have got a pole and the wind comes, it will make the pole to fall. But assume you have a strong wall. The wind comes and stops there. It cannot make the wall to fall. So what is lost? It's like a momentum. That's what I said. Everything starts with the momentum. It is not a great thing. It is a very small thing if you compare and then learn like this. Everything in physics starts with it is also a movement, it's also a motion. And Newton has clearly explained what is Newton's laws of motion. In which momentum says if you are very strong, a small boy comes and hits, the boy will fall. Assume that a small pillar is there and a strong person comes and hits, the pillar will fall. That's it. That's momentum. The mass and the velocity matters. The mass is huge. Velocity is also huge. Then I am sure that can be a black hole, that can be a quantum jump, everything can happen there. It's like you have got a glass and you are putting a small stone, the stone goes inside. Instead of that, imagine you are putting a very big ball. Actually, quantum jump is much more than the hole, which you will see. The whole things will spell out. You are doing PhD and you are doing paper on black hole, amma. Related to topics. These are all related topics. Understand the basics. Then, you will understand. So you are in a gravity. Which gravity? Earth gravity. Now we have to understand, we are talking about gravity, we are talking about quantum physics, we are talking about equation of motion. Everything is part of the explanations which you can give in black hole.
It will change according to black hole parameter.
Yeah, the mass, the energy, if it is velocity like in a quantum, in a momentum. So what are all the parameters? What is that? See, that is why every time we have got boundary conditions.
Boundary.
We have what is the condition? The boundary is moving or boundary is all stable. How strong is boundary? Every flow, every movement, boundary condition is very, very essential. Suppose your water is flowing in a canal. The canal boundary is very strong. Even though the force of water flowing is very huge, nothing will happen to the canal boundary. But assume canal boundary is not very strong. The water flow is too huge. The boundary will also go along with the water, right? So boundary conditions matters. So there are so many parameters which you have to consider. Now here what is the boundary? You have got a electromagnetic energy. Now so far we were explaining about a net ball is falling. So I am saying the ball is falling. Assume that you have got a basketball. Assume that the ball is not falling in the net. Suppose it is falling on the boundary where the iron rod is there. What could happen? Instead of falling inside, it jumps out, right?
Yes.
Now assume that it is falling at the edge where it is internalized. It need not fall straight down. It will fall in the another direction, right? Are you able to imagine? So what you can see around you, what you can visualize in a playground is what is happening in the whole universe in terms of whatever you call it as black hole. Oh, it disappears inside the net. Is it not space and time? Where, when, how, in which direction, what speed?
I understood.
You have to go to higher level. The highest level can be string theory.
String theory. String theory, then the dimensions are known in string theory.
So all these parameters which I told you, all of them become dimensions.
Each parameter will become dimension.
What is string theory? Vibrations, right?
Yes, the fundamental vibrating string.
Yeah, so it oscillates, it moves in a different direction, different style.
I never thought about black holes. That was a new thing which you told. I have never thought about
See,
it.
Nandini, I have no knowledge, but what I have is I had good students in my life. During discussion, something will come, they will tell me something. So that gave me a lot of ideas and start discussing around it. Assume over phone casually when you discuss, these things will not come from me.